Okay, today, guys, we're going to talk about properties of logs. In your book, this will be chapter 5.5. We're almost done with chapter 5. So properties of logs, as you can see, there's a lot of them. I would take a minute to pause the video. There's a few more I think I even left off of here, but in general, this is what you need to get by for the most part. So please take a minute, pause the video, and copy all of this down. Should take you a good 5, 6, 7 minutes to write all this down. And then come on back and we'll move on, okay? All right, so I wanted to just talk to you guys about a few of them. So right here, we have log base A of 1 is equal to 0. And this is what I was talking about in one of the previous videos, where we find that A is the base. So A to what power could give me a 1 as my answer? Well, if A isn't 1, then that would mean that A to the 0 would give me 1. Now, this is a kind of a nice one. Whenever you have a base and an argument that are the same thing, you get 1 as the answer. So A to the 1 is equal to A. So this is kind of a cool one that sometimes cleans problems up for you. This one, it's kind of the idea that a logarithm is an exponent, and these would cancel each other out. So you'll be left with M. So then you have M equals to that, okay? Or the A to that log would be M, okay? So that's one of the properties. It comes in sometimes. Now this one is basically, this guy right here is basically a variation of this guy right here. So I just want to show you guys that the ones that I feel come up the most, this one, well, what is that? This one comes up the most, this one comes up the most, this one comes up the most. And then these are oftentimes used in solving. Okay, so these ones, these three with the stars by it, these are extremely important ones. I mean, they're all important. You have to know them all, just like laws of exponents. You got to know laws of logs or properties of logs. This one says that if you have an argument in a logarithm that's being multiplied, you could split it as two separate argument or two separate logarithms. But that it's because it's an equal sign, that means it's a two-way street, so it can go backwards. So this also means now that if I'm over here on this side, then I could end up with one logarithm on this side, so it goes either way. So I could start over here and say, oh, I have two logs that have the same base, and I'm subtracting them. So then I could write them as one logarithm, but divide the arguments. So whichever way you need it to go for that particular problem, whether you're going to separate it into two separate logs, or you're going to put it together as one single log, either way you want to go, you can get it to work with these techniques. This one is really cool because a lot of times if you're trying to solve for the exponent, let's say that there's a t up here or an x up there, it's hard to solve for the exponent sometimes. So what the property of log says is that you can throw this in front. So you can move it to the front and put it right here and multiply it now by the log base A of M. So this is a way that you can bring powers down to the level playing field. So this comes up all the time. This one over here, number 8, we're going to use 8 and 9. We're going to use all the time in 5.6. If you have two things that are equal, then taking the log of those two things should not change that equality. It should still be balanced. If you have two logs that are equal and they have the same base, then you can just compare their arguments. Kind of like we did with exponents. Once you got exponents to be the same, once you got bases to be the same, you could then compare exponents. In this case, once the logs have the same base, and they're equal to each other, then you can just talk about their arguments. So we're going to use this all the time. This is called the change of base rule. And this is what we're going to do. This one I want to talk about when we actually go to do it. It'll make more sense. So for now, just kind of write it down and then I'll show it to you, okay? Oops. So let's go over here. So now it says use properties of logs to find the exact value of the following. So what I'm going to do is I'm going to use a property, and okay, so let's see here. Here's an exponent, and I'm going to move this to the front. So we're going to have negative 13 log base 2 of 2. Now I know that log base 2 of 2 is 1, so this is going to become negative 13 times 1, because that's one of the properties, so we get negative 13. Done. Okay, let's do this one. Now this is two logs that have the same base, and I'm adding. So I'm going to say that this is going to equal log base 6 of 9 times 4. Well, that will be log base 6 of 36. Now you could stop there, but you'd get marked wrong because you didn't simplify. Okay, we can make it even better. This is actually log base 6 of 6 squared. Now what can I do with that power? Can I move that power now to the front? So this will now become log base, oops, I have to write a little bit smaller, 2 log base 6 of 6. But we know log base 6 of 6 is 1, so this is 2 times 1, which is 2. Win again, okay? Now this one is using this power right here. This one doesn't come up as often, but we have to have it as one logarithm. So I'm going to say that this is 5 log 5 of 6 times 7, but that's 5 log 5 of 42. But remember, it says that it's just whatever the argument is because it's 5 log 5, 5 to the power of log base 5. So we just get 42. So that's how you can use properties of logs to kind of simplify things and clean things up. Now this one, I want to use, I think we should use change of base on this one. So this rule right here says that if you ever have a logarithm and you don't like the base you're working with, you can rewrite it into new bases. So notice this is some completely new base. Normally we use base 10 or base E, so natural log. But in this problem, I don't think we're going to use that. I think we're just going to try to clean it up. So this is going to become log base. Oh, well, I suppose I could do base 10 if I wanted to. Yeah, you know what? Let's do log base 10. So let's do log base 10 of 6 divided by log base 10 of 2 times log base 10 of 8 divided by log base 10 of 6. So I want you to keep in mind, this is how I memorize it when you're doing change of base. And remember, these are base of 10s. We just don't write it. When it's a base 10, we don't write it. It's invisible. Okay? So the way I remember it is when you're doing change of base, see how this one's a little above that one? Well, it's still above that one. You see how the 8 is above the 6? Well, the 8 is still above the 6. It's not really mathematical. It's just a way that I noticed to help me make sure that I don't get the change of base wrong. Okay, so let's see here. This will cancel with this, and then we'll be left with log base 10 of 8 divided by log base 10 of 2. And you cannot do this. Please do not cancel log base 10s. That does not work. That's not how logarithms work. It's log base 10 of 8, so it's a package deal. However, 8 is really 2 cubed, so I could rewrite this as log base 10 of 2 cubed over log base 10 of, oops, I don't need to be writing, or I don't need to write base 10. And this is log of 2. So then I can move the power to the front with one of my properties. Cancel my logs. Now I canceled the entire log base 2, I'm sorry, log base 10 of 2 and log base 10 of 2, and I'm just left with 3. And that's all I got. That is my final answer. So this is how we can use properties of logs to simplify our work, make things a lot nicer. And this is something you have to get really good at. This comes up in Calc 1, Calc 2 all the time, manipulating logarithms, manipulating exponents. It's a skill set you really want to develop to move forward. Okay, let's see what else I got in here. So I want to show you guys something that I like because you kind of can't use your calculator, you kind of can't, you just have to know what you're doing. So suppose that I say that the natural log of 2 is worth A, and the natural log of 3 is worth B. Now, you can type in your calculator a decimal and get the natural log of 3 and the natural log of 2. That's not what this is about. I want you guys to say, to use properties of logs to write the following in terms of A and B, okay? So what that means is, let's say that I give you natural log of 6, okay? So what this means is I want you to rewrite the natural log of 6 in terms of A's and B's. So that means that this is the natural log of 2 times 3, right? Because 2 times 3 is 6. But I am now multiplying my argument, so I can use way up here. I can use this property, right? I can use this guy right here. And I can use that guy to split this as the natural log of 2 plus the natural log of 3. However, it says that the natural log of 2 is worth A and the natural log of 3 is worth B. So this just becomes A plus B. And that's it. You're done. So I want to write it. There's a few of these in your homework as well. I want to write a few of these out for you guys. So let me see. Natural log of 27. And let's do natural log of 0.5. And then I think I have a worse one around here somewhere. Let's just make one up. Let's do the natural log of the cube root of, let's say, 9 over 8. Nope, not over 8. Say 9 over 4. Okay. All right, so pause the video and give these a shot. Okay, so hopefully you guys are back. And the first thing you did was you rewrote this as 3 cubed, because the natural log of 27 is just 3 times 3 times 3. So then this just becomes 3 natural log of 3. But we know that the natural log of 3 is worth B, so this becomes 3B, and there's your answer. Now, 0.5, you have to think, what is 0.5? Well, 0.5 is really 1 over 2. And the natural log of 1 divided by 2 is the natural log of 1 minus the natural log of 2, right? Because it's division, we're allowed to separate these two logarithms by subtraction. And then this will become, well, the natural log of 1 is 0 minus A, so we get negative A. Okay. Now this last one, I'll give you a minute, maybe pause the video and see if you can kind of use some cool stuff on this one. All right, so hopefully you thought about the cube root as a power. So this becomes 9 over 4 to the 1/3 power. But then that becomes 1/3 natural log of 9 over 4. But that becomes 1/3 natural log of 9 minus 1/3 natural log of 4. And you have to put the 1/3 to both of them, because they're both being multiplied. The whole natural log was being multiplied by 1/3. So now this will become the 1/3 natural log of 3 squared minus 1/3 natural log of 2 squared. So I think you guys see it now. This will be 2/3 natural log of 3 minus 2/3 natural log of 2. But you guys know that's 2/3. I guess we could factor it out. B minus A. And that would be our answer for that. So these are kind of cool because your calculator kind of can't save you. You actually have to know what you're doing, because, you know, this is actually saying that the natural log of 2 is worth A. That's not what it's actually worth. We're just saying that's what it is for these particular problems. So I think this is a good way to test you guys on your ability to manipulate logarithms. All right, so make sure you know how to do this. I believe I put a few of these in the homework. Okay. So let me see here. Let's write each expression. So let's practice writing expressions. As a sum or difference of logs. Okay, and I'd also like you to express powers as factors. And you'll see what I mean in a second about that. Okay, so suppose we have log base 3 of x over 9. Okay, so I want to rewrite this as the sum or difference of logs. I don't want to write it as one log. So this will then become log base 3 of x minus log base 3 of 9, right? And then 9 is really 3 squared. So this is going to be log base 3 of x minus log base 3 of 3 squared. But that will be really log base 3 of x minus 2. Because once we put the power in front, log base 3 of 3 is just going to be 1. Oops. So that would be the answer. So that's what I'm talking about when I mean that, when I say it that way. So let's look at another one. Let's say we have the natural log of x e to the x. And over here, let's say we have the natural log of e over x. Let me see if I have a better one. Let's do log base 5 of x squared y cubed over the square root of z. Yeah, that's a good one, okay? So pause the video and give these three a shot, and let's see what happens. All right, so hopefully you guys did this. Natural log of x plus natural log of e to the x, but that's actually natural log of x plus x, and we're done. This one is the natural log of e minus the natural log of x. And remember, you guys, all I'm doing is I'm just using these properties up here over and over again, especially, like I told you earlier, this one and this one. They come in so handy, and then I come back to this one all the time too. So let's go over here. This was division, so I just put a subtraction sign. Now remember, they're the same base. They're both natural logs. That means they're base e. However, natural log of e is 1. So this becomes 1 minus the natural log, or ln of x. And this would be our answer, okay? Now this one takes a little bit longer. It's not worse, it just takes longer. So this is log base 5. So we're going to split this as log base 5 of x squared plus log base 5 of y cubed minus log base 5 of z to the 1/2 power, because I'm going to rewrite the square root as a 1/2 power. So now this will become 2 log base 5 of x. And that's what I mean when I say write the power as a factor. That means you got to move it to the front and multiply it times 2. Plus 3 log base 5 of y minus 1/2 log base 5 of z. And that would be our answer, okay? So remember, you always have to simplify everything when you're done. Okay. Now let's go the other way. Write the following as a single log. Okay, so then we're going to give stuff like this: log base 2 of x plus log base 2 of x minus 3, so that'll be 1. Then we have natural log of x minus 2 plus 1/2 natural log of x minus 5 natural log of x plus 3. Okay, so let me write one more down, maybe 2. Let's see here. Oh, I think this is a good one too. Log of x squared plus 3x plus 2 minus 2 log x plus 1. Yeah, I like that one. So we can do that one right now too. All right, so you know what? I got one more. I like this one too. Log base 2 of 1 over x plus log base 2 of 1 over x squared. Okay, so the reason I kind of like these problems is because this is kind of like I don't want to say you're showing off, but you're almost like kind of flexing how much you can manipulate logarithms. But this is where I see a lot of people make a mistake. So this first one's easy. And notice in all of these problems, they're both the same bases. Here, this is log base 10s. So we got log base 10s here, right? Even though we didn't write it. And that's kind of the key, is these all, they're the same base. When they're dealing with each other, they're all the same bases. So this one means we can combine them. So this will become log base 2 of x times x minus 3. So normally they might ask you to factor or FOIL this out. So x squared minus 3x. So that would be our problem there. No big deal. Okay. Now this one over here looks a little worse because it's longer. So we're on this one now. So this would be natural log, and they're all natural logs, so I can combine them. Natural log of x minus 2. Now here's the rub. You cannot combine a logarithm until you move the factors out of there. So we got to get rid of these factors. So what I'm going to do is I'm going to rewrite this first, ln of x minus 2. Whenever you're trying to put logarithms together, there always has to be a 1 in front. So this is plus ln of x to the 1/2 power minus ln of x plus 3 to the 5th power. So I put the powers back. Now I can combine them. So I'm going to have natural log of x minus 2 times x to the 1/2 all over x plus 3 to the 5th, okay? So hopefully you guys see why that could be a little bit of a pain. A lot of people forget to move the exponents. They forget to move those factors back into the exponent. If you have a number directly in front of a logarithm, that means it was really a power of the argument. So this would be, oops, this would turn out to be our answer right here. Okay. So now let's take a look at this one. Okay, so this one's kind of a cool one. Log of x squared plus 3x plus 2. Now this is actually, I should write this here. I'll just show you guys. This is log x plus 1 squared. So I put it back, right? Over, and then this will become x plus 1 quantity squared. But here's the problem. X squared plus 3x plus 2 is factorable. So this is x plus 2 times x plus 1 all over x plus 1 squared. We actually can cancel. So that cancels with that, and that just leaves 1 behind. And now we're left with log base 10 of x plus 2 over x plus 1. Nice one. That's a pretty cool one. That one I might try to throw on the test. Let's look at this other one. This is another cool one. Log base 2 of x to the negative 1 plus log base 2 of x to the negative, negative 2. So this will become log base 2 of x to the negative 1 times x to the negative 2, right? I put them as one log because they were addition. I could multiply. So this becomes log base 2 of x to the negative 3. Okay, so not so bad. All right. Now, I think the last thing I want to talk about in this section will be the change of base. Okay, so let's talk about change of base. So the change of base was this guy way up here. He was this guy right here. Okay, so we did one of these already, but I just want you guys to do a calculation with it. So suppose I want to know log, now your calculators can also do this, but I want you to get comfortable using the change of base to get it into a format that any calculator could do. So we're going to change bases to always base 10 or base E, natural log, when we're trying to do a calculation, just because those are the ones that almost all calculators have programmed into them. So if I say log base 5 of 18, because you guys have the newer calculators, it'll still do it, but I want to do the old-fashioned way with the change of base. So I'm going to do log base 10 of 18 over log base 10 of 5. So I'm literally going to take out my calculator, and I'm just going to do log of 18 and hit enter. And then I'm going to do divided by log of 5 and hit enter. And I get 1.7959 if we round off. Okay. In general, with logs, you could normally do 4 decimal places unless somebody tells you to do it otherwise. So I could do the exact same problem. I just want to show you guys something with natural logs. So I could do ln of 18 divided by ln of 5. So on my calculator, I'm going to do the natural log of 18 divided by the natural log of 5. And I get the exact same answer. Right, so the change of base, sometimes you can use it for simplifying, but a lot of times you use it to make it so your calculator, like the common calculator, could do it. Let's do one more. Let's do log base 7 of 25, okay? So you guys take out your calculators and plug this in, And remember, since this guy is kind of on top and this guy's kind of on bottom, when I do my change of base, it'll stay the same. So I'm going to do natural log of 25 divided by the natural log of 7. So natural log of 25 divided by the natural log of 7. I get 1.6542, I guess. So that's my answer, that's my answer, that's my answer, okay? So that's basically the change of base, no big deal. And I think that's it for this section, going through the notes. Yep, that'll do it. So that's all for 5.5 and properties of logs. Again, make sure you guys practice these homework problems a lot. These are really important for moving on in calculus. There's a lot of, natural logs and exponential functions and logarithms in calculus. All right, you guys, thanks for watching.